So let us quickly look at some of the multiple choice questions. Question number 1. Out of the following options, which can be used to produce a propagating electromagnetic wave? Now, first of all, even before we look at the options, what do we need for an electromagnetic wave? So, an electromagnetic wave must have an electric field. It must have a magnetic field such that the electric field and the magnetic field are perpendicular to each other and also perpendicular to the propagation of wave. So that's the requirement. Now let's look at the option. First option is stationary charge. Now stationary charge means the charge is at rest. Right? So a charge at rest will only have electric field. There will be no magnetic field. Right? So this is not the correct option. Option B, a chargeless particle. So if the particle doesn't have any charge at all, so obviously there would be no magnetic field, no electric field. So this is also not the right option. Third option is accelerating charge. Now since it is a charge, it will have an electric field. Now since the charge is also accelerating, that means its speed is also changing with time. So that means it would also have a magnetic field as well. So here we have an electric field as well as magnetic field which are changing with time because the charge is accelerating. So it seems to be a correct option because this can produce an electromagnetic wave. How about the option D, a charge moving at constant velocity? So in this case, even though we have a charge, but it is moving at constant velocity. That means acceleration is equal to 0. So in this case, even though we have an electric field or a magnetic field, but they do not change with time. So therefore, option D is also not the right option. Question number 2. The electric vector vibration of an electromagnetic wave is given by E is equal to 50 Newton per Coulomb sine omega t minus x by c. The intensity of the wave is. So just now we discussed about the properties of electromagnetic wave and we found out that intensity of an electromagnetic wave is given by half epsilon naught E naught square into c. In fact, in this question electric field is given, so we have considered this expression involving electric field. Had magnetic field been given, in that case we would have involved the expression 1 by 2 b square by mu naught into c. Right? Okay, so in this case, what are the values that we need? So epsilon naught is permittivity in free space which has a fixed value, that is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter. Okay, what about E naught? So here if you look at this expression, you can compare it with this expression. E is equal to E naught sine omega t minus omega x by c. Right? So here you see the value of E naught is basically this value. So 50 Newton per Coulomb is the value of E naught. So E naught is 50 Newton per Coulomb. Okay. And the value of C is 3 into 10 to the power 8 meter per second. So now we know all the values. So let's calculate intensity. It would be half into 8.85 into 10 to the power minus 12 into 50 into 50 into 3 into 10 to the power 8. Right? So 2 into 25 is 50. So now when you do this, you get 33187.5 into 10 to the power minus 4, which is equal to 3.3 Weber per meter square. So that is C is the correct option. Question number 3. In case of linearly polarized light, the magnitude of the electric field vector does not change with time, varies periodically with time, is parallel to the direction of propagation, increases and decreases linearly with time. So first of all, you have to understand what do we mean by linearly polarized light. So a linearly polarized light is always in the form of electromagnetic wave. And what happens to the magnitude of electric field vector in electromagnetic wave? Does it remain constant? No, it varies. And how does it vary? It varies periodically with time. So if you have observed the variation of electric field and magnetic field, if the electric field varies like this, the magnetic field varies like this, like parallel, perpendicular to the electric field, somewhat like this, correct? So B is the correct option. Question number 4. The energy of gamma ray photon is E gamma and that of an X-ray photon is Ex. If the visible light photon has an energy of EV, then we can say that. So basically we need to compare the energy of gamma ray photon, X-ray photon and visible light photon. Okay, so all of these are part of the electromagnetic spectrum. So if you quickly look at the electromagnetic spectrum, this is how it looks like. Now, which are the rays that we are concerned about in this question? We are concerned about the gamma ray, X-ray and visible light. And where are they located on this list? So this is visible rays, this is gamma ray and this is X-ray. So we are concerned about these three things. So looking at these three things, you can say that the wavelength of visible light is greater than the wavelength of X-ray, which in turn is greater than the wavelength of gamma ray, right? Because as we go up, the wavelength increases. Now we know that energy is equal to hc by lambda, right? So energy is inversely proportional to wavelength. That means a ray with more wavelength will have less energy. So therefore we can say that energy of visible light. Now if we talk about wavelength, then the wavelength of visible light is maximum. So if we talk about energy, the energy of visible light will be minimum. So we can say that E visible light is less than energy of X-ray is less than energy of gamma ray. So which is the correct option? It is option C. Question number 5. A plain electromagnetic wave of frequency 20 megahertz travels through a space along x direction. Okay. If the electric field vector at a certain point in space is 6 volt per meter, then what is the magnetic field vector at that point? Okay. So whenever we talk about an electromagnetic wave, we definitely talk about both electric field and magnetic field. Now at any point, what is the relationship between electric field and magnetic field? So at any point, electric field and magnetic field, their ratio is equal to the speed of the electromagnetic wave, right? So we can say that the magnetic field will be equal to electric field divided by C. So in this case, the value of the electric field vector at the point is 6 volts. So E is 6 volts and 6 volts per meter and speed of light is 3 into 10 to the power 8. So this is equal to 2 into 10 to the power minus 8 Tesla. That is option A. Question number 6. In electromagnetic spectrum, the frequencies of gamma rays and X-rays and ultraviolet rays are denoted by N1, N2 and N3 respectively. Then, so basically we need to find out relationship between frequencies of these three radiations. Again, these are all part of the electromagnetic radiation. So we will quickly recall the electromagnetic radiation list, and here we see gamma, ultraviolet rays, X-ray and gamma rays. So looking at this, you can say that the wavelength of ultraviolet ray, so ultraviolet ray is denoted by N3. So basically wavelength of ultraviolet ray is greater than wavelength of X-ray is greater than wavelength of gamma ray. So ultraviolet ray is denoted by N3. Now wavelength and frequencies are inversely proportional to each other. So we can say that frequency of ultraviolet ray is less than frequency of X-ray is less than frequency of gamma ray. So frequency of ultraviolet ray is given by N3 in this question. So N3 is less than, X-ray is given by N2 and gamma ray is given as N1. So we can say N3 is less than, N2 is less than N1. So basically option A is the correct option. Question number 7. The electric field associated with an electromagnetic wave in vacuum is given by E is equal to 40I cos kz minus 6 into 10 to the power 8t, where E, Z and T are in volt per meter, meter and second respectively. The value of wave vector K is. Now what is the generalized expression for electric field associated with an electromagnetic wave? It is given as E is equal to E naught sine kz plus omega t. Something in this pattern, right? Okay, so in this question, if you compare this general expression with the expression which is given in the question, you can compare and see that the value of omega is given as 6 into 10 to the power 8. So omega is given as 6 into 10 to the power 8 in the question. Now we know that omega is equal to 2 pi nu. Omega is angular frequency, which is equal to 2 pi nu, where nu is linear frequency. So this is equal to 6 into 10 to the power 8. Perfect. Okay. Now let us talk about wave vector k. So wave vector k is given by 2 pi by lambda. Right? So how can we write lambda? Because we do not know the value of lambda. But from here in this expression, we know the value of nu. Right? So value of nu is 6 into 10 to the power 8 by 2 pi. So is there any way by which nu and lambda are connected? Frequency and lambda are connected? Yes, of course. So we know that nu is equal to c by lambda. Or we can say 1 by lambda is equal to nu by c. So therefore instead of 1 by lambda we can write it as nu by c. So therefore this is equal to 2 pi into, now we can put the value of nu here. This would be 6 into 10 to the power 8 divided by 2 pi into c. So 2 pi will cancel. So this is 6 into 10 to the power 8 divided by c, which is 3 into 10 to the power 8. So 3 2s are 6. 10 to the power 8, 10 to the power 8 would cancel. So the value